Ever wondered what happens when you run a program in your computer? How is it compiled? How is it processed? And how is it executed? How you see the output? So in this video, we will be diving deeper into the concepts of compiler design, its phases, in the concepts of operating system, and how you see the output. We have a very simple program in front of us. This program is basically returning 8 as an output. So it looks simple, but behind the scene, a dozen of things are going on in your computer. We have different phases through which your code is going to pass. So the first phase is called the pre-processing phase. In this phase, your compiler expands your header files. It replaces your macros with the value you have assigned. And if your code has any sort of comments, it basically removes them since they are not needed in further computation. So you can think of it like you are having all the ingredients in front of you before you just start cooking. So here the compiler is your chef. The next phase is called the lexical analysis phase. In this phase, your code is now broken down into tokens. Further from here, your compiler is not going to understand the code as you gave. It is going to understand your code in terms of tokens. Tokens are of different types. These are keywords, identifiers, operator, constant, delimiters, string identifiers. So you can see the table for some examples. The smallest unit in which the code can be broken down is called a lexeme. So it is another name for the token. And so for the further phases, these lexemes would be used. The next phase is called the syntax analysis phase. This basically checks if the language you are using, are you following the rules of that. So if you are using C++, you have to follow the rules of C++. If you are using Python, so respectively you will be following the rules of Python. So this is the syntax analysis phase in which you have to follow the language rules which you are using. If you are not doing so, you will get a syntax error. For an example, if you have not added this sign, the semicolon, you will be getting error in C++, since this is defined as a rule in the C++ language. The compiler uses a parse tree to check if your code is correct syntactically or not. And you can dive deeper how this parse tree is made, what are the methods to make it. But for now, we will be moving on to the semantic analysis phase, which is the next phase. Once your code is having the language rules being followed, the next phase is called the semantic analysis phase. In this phase, we basically check, are you talking meaningful? Though you are using correct grammar, but is your sentence making any sense to me? So for an example, you can't add a character to an integer. So this is not a syntax error, but this is a semantic error. This is making no sense to the compiler. So we are just going to see if the code is correct or not. Is it meaningful or not? After this phase, we have the intermediate code generation part. This part is really helpful for virtual machines. So you can dive again deeper how virtual machines are used. We also call the intermediate code as bytecode sometimes. So since the Java virtual machine uses bytecode for its interpreter, so in this phase, basically we have a 3-address code generation. So your code is now broken down into 3 address parts, instructions. So basically you can see all the things are now written in 3 addresses, not more than 3 addresses. This intermediate code generation is now helping your machine to get closer to the machine level code. After this, we will be having the optimization phase. The compiler now improves it. It removes unnecessary steps, makes it faster without changing what it does. It analyzes, applies optimization techniques, preserves semantics, improves efficiency. This is often done using the help of registers. And after this phase, you get the target code generation. In the target code generation, it is finally machine level instructions like load, add, store. These are all machine level instructions. Now the compiler is going to see instructions, not the program which you gave. After this phase, once the code is generated into a machine level code, now the operating system part will take over. The operating system part basically has a process, memory, and a place in the system. So your program now becomes a process. The basic difference between a program and process is that program is given by the user, and when it gets executed or while it is being executed, so it is a process in your operating system. It is given a memory, it is given a process ID and a place where it can be managed, and it is being tracked by the operating system. So what is to be given memory, what is to be given and being swapped with the main memory and the disk is basically done using your kernel. So kernel is the main computing part of your operating system. The next phase we will be talking about the memory layout. In the memory layout, a basic process always has stack, heap, data segment, text, and a kernel space. In the stack, you hold function calls, the local variables, parameters, return addresses. In heap, you store the dynamic memory allocation variables. Often we use new in C++, malloc in C, etc. So in the data segment part, you store the global variables, static variables, and it can be initialized or uninitialized. The next stores the code segment. It is basically the instructions which your program had given earlier, since your program is now converted into instructions in the operating system. And then you have a kernel space associated with your process. It is reserved memory for the operating system, not accessible to the user program. The next thing which we are going to talk about is the CPU entry, how the program starts execution. So for being executed, your program needs CPU. So there are tons of programs going on in your computer. You have loaded many programs in your RAM at a time. This is called multi-programming. So often people get confused between multi-programming and multi-processing. Multi-processing is done using cores, threads, whereas multi-programming is done when you can load multiple processes into the RAM so that your CPU is never free. We don't want any computation cycle to get wasted. So the CPU swaps your processes one by one. It can follow different type of cycles. You might have heard about round robin method, first come first serve methods, shortest job first method. So it depends how your process is getting allocated to the CPU. So once it is being processed, the next thing which we have is the instruction cycle. This is a basic instruction cycle which we study basically in the computer organization and architecture part. The cycle consists of fetch, decode, execute, and again after execution the PC is updated to point to the next instruction. So PC is basically your program counter which points to the next instruction of your program which is getting executed right now. After this phase we have the scheduling part. So already I have covered this operating system scheduling part. You can have different type of scheduling algorithms being implemented in your CPU. It can be a shortest job first, it can be FCFS, it can be anything, it can be a round robin method. So these are different kind of methods which are used in CPU scheduling so that you can have multitasking being done. So it involves multi-programming, it involves multi-processing. Multi-processing is in turn being done using threads, using multiple cores. So we are not requiring n number of CPUs, but our CPU can have n number of cores. That is also contributing to the multiprocessing part. We can run different threads of the same process. So you can dive, and you should dive deeper into how and what is the difference between making different processes and making different threads out of that process. So you basically share some of the things in common in the process memory. So out of this memory thing, you share some of the things in common when you have different threads. So I will not be going out of the topic. We are basically learning how the program executes. You can dive deeper into it and you should be researching about it. After the scheduling part, we have the output part, and once everything is executed, your value 8 or 10 whatsoever your code wanted is now going to be the output of the code. So these are the steps which are followed and you should always have a clear idea in your mind how the compiler works, how the operating system works, and how your computer architecture is getting involved in the instruction cycle, so that a final mind map can be made, that you have a source code, it goes through the compiler phases, it becomes the object code, it goes into the operating system, it gets some RAM. So over here also you have different algorithms for memory management. We can use virtual memory, which is again using RAM in turn. So you get the CPU on which you get scheduling algorithms being implemented, and finally you get the output. So we have left over many things, like you didn't see any type of queue in the operating system. While your code uses scheduling algorithm, you have different type of queues. You have waiting queue, you have ready queue. So these are the parts of operating system. But this video's aim was to give an image to your mind and make you conceptually clear that where is the part of compiler coming into play, where is the part of operating system. So I hope you enjoyed the video, and now when you study operating system you clearly know that why is it coming into play and where is it involved in my programming or any kind of stuff you are performing. So we will be diving deeper into conceptual things of computer science. So I request you to subscribe this channel, click the bell icon, and thanks for watching.